Hey everyone, so today I got a University of Toronto junior. He's a student there and he's going to go through a coding interview. So could you just give a quick background on yourself and also how many leak code questions you solved?
Yeah, I'm currently a rising junior at U of T. My leak code I've done around like 220-ish questions. So mostly the Nico 150, some of them, and then some random like daily problems for a while.
I see. So where have you interviewed so far?
Um, Last cycle, I guess the two ones I can remember, I interviewed at eBay and Amazon,
Nice.
and yeah, I failed both of them. So
So you're just trying to make sure you never
yeah,
fail it again?
something like that.
Alright, okay, we got this. So you did a lot of leak code questions since then? So you've been
Yeah, I
practicing?
would. Yeah, I would say last year I was pretty active on League Code. This year not so much, but I do want a couple here and there.
All right. Okay. Let me come up with some good questions. Give me a sec. Let me let me find you some good questions just to set it up. Okay, I got the first question in. I'll post it in. So we're basically giving a flower bed in which some of the plots are planted and some are not. However, some flowers cannot be planted or flowers can't be planted next to each other. So I'm gonna post the examples here. So basically, what we're trying to do is we're trying to plant flowers in a flower bed. And we want to see if we can plant and flowers. So the main constraint is that we can't plant a flower next to where another flower is. So this one is true because we can plant a flower here. This one is false because we can only plant the flower here, that's one. And now we can't plant the flower anywhere else. Does that make
Yeah, I
sense?
see. Yeah. Seems pretty simple enough, but I'm wondering if there's any trick to it.
Uh-huh.
So I'll just work with this example here. Uh, okay, so it's like a valid. Maybe I'll move it down here. So if you're assuming it's valid, and let's say we want to plant two flowers, um, can you see the pointer thing I'm putting
Yep.
on?
Yep.
Yeah, so we can like just kind of loop over and then check if you can place a flower here. So obviously we can't, and then we'll move on to this position. Um, then we'll ask, well, could we potentially place a flower here? So we'll look left and right, and obviously make sure it's inbound. And then, and if it is valid, we can place a flower here, and then decrement this by one. Go over here. We can ask the same question, and then we'll see. We'll check left and right, and we'll see if we can't plan it. Yeah, we'll kind of exit the loop, and then we'll essentially return if n is equal to 0.
Sure.
Cool. So let's say call it can't plan. Let's call it an array. Um, we can let's loop over the array.
Looping through the arrays. Wait. Are you,
Yeah.
okay, sorry. You went
So
blank, so I thought my
just
audio
right.
went tweak.
Yeah, sorry. So now I just want to essentially the first position. Let's say I want to check my I minus one and my I plus one. Um, but before I do that, I want to make sure I don't have any indexing errors. So maybe I can do those checks manually. Maybe. Uh, So I guess one question I want to ask, if I have a situation like this where I have like two empties here, could I potentially plant one here as well or no?
You can plant one on the edges. As long as it's not touching, as long as there's not a one right there, you're good.
Okay, cool. Yeah, maybe I'll start. I'll loop from I'll loop from the first index to like the n-1 index, essentially. So that way I can just directly check like the out of bounds error and stuff. And
Yep.
then before I go into there, I'll just manually check the first and last position, if that makes sense.
Yep.
So if there's already a flower, if it's equal to 1, we don't really want to do anything with it. So right now that means it's empty. That means so the left position must be 0 and the right position must be 0. So we can place a flower here. And sorry, so we need to take an N here as well. So after this loop executes, we'll have placed all the flowers in the middle, and then right now we just need to check. We need to check the 0th index and the last index. So if the first position is empty and the right position is also empty, we could potentially get into some indexing errors here as well. This is not a very clean solution, but I could do something like if the length is greater than or equal to 2, then I have the second index, and I can do the same for the last position as well. Just let me think how I can kind of put it in the code as well. Okay.
So for I in range 1 to array 1, if array equals 1, continue. If array equals.
Yeah, so let's just loop through the whole array. Let's get rid of the. So right now we're definitely at empty spot. So I'll have some conditional. So if I is 0, we'll say pass for now. And if I is n-1, or not n, length array -1, we'll do something else. So if we're at the first index, then we want to check the next index. We know it's a 0. So if array of 1 is equal to 0, then
What
it's
if that's
empty.
out of bounds?
But if it's out of bounds, so so essentially we want to make sure so there's at least two things, like the array length is at least 2, then we can essentially check the first index.
Sure.
And yeah, if that's so, then we can just place 1 here, decrement n, and we can do the same thing. So if the last index is empty, sorry, okay, if -2, so before that we can do the same check. I think this should be it. Let me just do like a quick dry run for one of the examples. Yeah, so we'll come over here. We'll see this is not valid. This is the first valid position we'll find. We'll change it to 1. We'll decrement this. We'll come over here, say this. We'll see this is not valid. We'll
Walk
come
me
here.
through line by line the actual code here.
Oh, sorry, yeah. So
Start at 0.
Yeah, let's restart. So yeah, so we'll come to the 0th index. We'll see there's already a flower here, so we won't do anything with it. We'll come to the 2nd index. Well, there's not a flower here, so we're gonna enter the if condition. And then, well, I is not the first index or the last index, so we can easily check the left and right bounds. So we'll check the left index, and we'll see that this is not 0. So we'll just skip this one. Like this if statement won't execute. So we'll go to the second index. We'll enter here again, and then here this if statement will execute. So here both of these satisfy. So the I-1 and I+1 are both 0. So we'll plant the flower here. We'll decrement n. Yeah, we'll go forward again. We'll enter this if statement here because it is a 0. So, and then, well, none of the checks would satisfy. So we would not do anything. We'll go here. So we would enter, since it's 0, it would just get skipped. We would exit the for loop. So n would be on 1. And then we would check if we were able to plant all the flowers, and this would return false.
If the length of the array is greater than 2, an array, what's this? Array -2?
This would be like the second last index, or n-2. Maybe that one looks.
This doesn't look like it's gonna work if, like, pretend we have 0, 0, 0, 0, 0. Like n equals 1.
Okay, let's see.
Actually,
yeah, so it would come here.
Where's this return happening? Is this in the for loop or no?
Oh yeah, sorry, it should be outside the for loop. Yeah, we're essentially decrementing however many we can plant. And then we're just checking if we were able to plant everything.
Well, like, what would happen if all of them are 0s and n is the only 1?
Then, so let's see. It would enter here. And then, oh yeah, I see. Yeah, well, I would have to, even before so yeah, that makes sense. So maybe if n, so as soon as if we ever hit this, we'll return true, and then if we exit the loop, we'll just return false. So for this condition, for for this example, so it will not, zeroth position will not get skipped. We'll come over here. We'll check the length is greater than 2. And the second position, essentially, this position is also 0. So we'll change I. This would be I. This would change this to 1, and we would decrement n. And then after the loop, after the if statements, we'll check if it's 0. It is. So it will just return true.
Okay. Let's see. Yeah, that works a bit better. Let me see.
But I guess the implementation is still a bit dodgy, I would say.
Yeah, is there any way to clean this up?
Yeah, so mostly just the indexing errors. So is it okay if I just like erase this and start from scratch again, or we wouldn't have time
No.
for
Keep
that?
it. Keep it.
Keep it? Okay. Yeah, so
Okay, it's breaking on this. It's not working on this edge case.
yeah, I would definitely have to implement this better.
So this one should actually return true.
Yeah, so it's skipping this one. Yeah, this is pretty dodgy implementation.
Or like, why should this one return true?
Yeah, because n is my code is never getting to this point, so maybe we can just do that. Then just nest all these.
0.
So if it is open spot, then investigate it. If not, then don't. So this will always execute.
If array I equals 0, investigate it. This will still return. It's not gonna return the right thing here. Right? This should return. It returned true. Wait, if.
So yeah, so this will on the first call it will just essentially skip everything, and then yeah, we'll just hit this one.
Let's see. Just run it on my. Okay, run it on this case.
Oh yeah, this is not good at all. Yeah, I guess the only place where
this is breaking on this case.
Yeah, this would be the only problem. So if the length is 1, and if length is 1, and can't think of anything for this. So implement. So essentially, if our array is this, then n must be 0. But yeah. Yeah, this seems like a pretty easy question,
Hmm.
but it's 2 a.m. from where I'm, so I can't really. I don't know why I can't really get to like implementation of this.
Let's see.
But
Okay, the problem is it's zero, right? You're looking at
yeah,
zero. So if the I
so
is
this
equal to
would be
zero,
true. Yeah.
this is true, right? But if the length of array is not equal to two, so I think you need to just generalize your algorithm more.
Yeah, so I would just have to kind of somehow. Mm, okay. Some How I'm thinking is maybe we can have some type of boolean for left and right, and
Like
then
how could you generalize your left here? How can you always look left? As in,
how can I always look
like
left?
here, how can you look left without all these extra conditions? Or I guess when you're when you look left, what should the number be?
It should be like greater than or equal to 0, essentially.
Or what if you look left and you're in the boundary though, like you're at the end,
Um, if I look left and there's like a
and you're at
one
the
beside
first
it.
element. If you
Yeah,
look
so
left and you're at the first element, what should the number be to the left?
0.
Exactly. So what if you just do like, you just look left and you look right, but you have a small condition. We'll say it's gonna be zero if I minus one is less than zero, else array I minus one. You see how that would work?
Yeah, so this would return. Yeah.
Okay, now try that for the right, and then try to generalize your algorithm after that.
Give me something like that. So left is either 0 if it's
Five plus one
it's
is three.
automatically set to 0 if it's
Good.
inbound. Oh yeah, sorry about that. Yeah, if it's inbound, then sorry, if it's out of bound, then it's automatically 0, or else it's the value. And right is if it's inbound. If it's inbound, then it's a value, or else it's automatically set default to 0. And if we are at an empty position and left is 0 and right is 0, then place a flower, decrement n, and if we ever get to plant all the flowers, return true or else return false. I
Let's see.
guess that, yeah,
Nice. Let's see if we run
that
this.
seems much cleaner.
If n equals zero. And one thing you should just add is like if n equals zero off the jump, just return true.
Yeah,
Right? Because if there's n equals zero,
then
there's
it's,
nothing to
yeah, it's
plant. You're
automatic.
good, right?
Absolutely.
You good for another question or you're cooked now? Let's see.
No, let me try. Let me try one
Okay,
more.
okay, okay. Let's see. Okay, I just ran on LeetCode. Tesco Green. Richie Rich, yeah, I can do interviews tomorrow if you need one. You gotta sleep tonight? Okay.
So that's easy, right?
Yeah, that's just a warm
Yeah.
up. Okay, lock in, lock in.
I gotta redeem myself, chill.
Okay. Okay, you're given an array of colors in which there are three colors: one, twos, and threes. You're also given some queries, and I'll give it Richie Richard in Toronto. We got a couple of people from Toronto. Let's see. So you're given an array of colors, and you're given a bunch of queries. Each query consists of two integers, I and C. Return the shortest distance between the index I and the target color C. So for query 1, we want to find the furthest one is from a 3. It's 3 away, right? For 2, index 2, we want to find the furthest it is from a 2. It's right on a 2, so that returns 0. And then for index 6, 0, 1, 2, 3, 4, 5, 6, it wants us to see how far we are away from a 1, and that's also 3. Right?
Yeah, so
Did
one,
you get the
two-
question?
Yeah, I think so. So go through each query. So this is the index, and this is the target color, and then you could either go left or right until, and you want the maximal distance, not the minimum distance. Oh, sorry, the minimum distance, not the shortest distance. Okay, and if it ever goes out of bound, then just return -1. Cool. So let's go from here. So at the first query, so we want to go to the first index, say here. And then we want to traverse, we want to check if it's already at color 3. It's not, so it's essentially like go left and right till you find color 3 if you can. And if it's out of bound, like it's just -1. So maybe we can go left as much as we can. And then we won't find a solution here. We could go 1, let me put another pointer here. We could go 3 this way, and then we'll locate a 3 here. So we'll store this answer as 3. And yeah, we'll just do that for each of the queries. So I guess that would be a brute force way to do that.
So at each one, you're going to look where? To the left or to the right? So pretend I look at index 1. And I need to look for a 3. How do I find the 3?
Yes, since these are not sorted or anything, each query consists of 2 integers. I see. Yeah, it doesn't mention anything about sorted or anything, so I guess we would have to look in both directions, right?
Yeah.
But yeah, so we would have to. Let me see if there's anything more efficient.
You have to look in both directions for a 3. And how would you find it? Like, how would you find it? Yeah.
Yeah, essentially, I'll just start iterating to the right from here, and as soon as I hit a 3, like that I could calculate that like the j minus I, and if I never find it, essentially, like we just. So if I never find it, I just put -1.
Yeah. So what would be the runtime complexity of that? Pretend we look at 1, we look for a 3. We look
Yeah,
for
I
1
guess.
again, and we look for a 3. Pretend all the queries are one looking at index 1 and 3, and 3 was at the very end.
Yeah, so if you had something like this, then if you had something like this, and
even just 1, and then we kept asking for this one.
Yeah.
And we kept looking for 3.
Yeah, from here it'll just be essentially n squared. Let's say if you wanted to look for 3 n times, so go from here, essentially would come up all the way here, and then repeat it for every single position.
Yeah.
So we would just be recreating that pattern. So yeah, maybe some sort of prefix array or something like that. Or maybe it could be yeah, I don't think I can sort it because then I would lose like the ordering. I would lose the ordering of. Yeah, I could definitely not sort the colors. Then if I need a bigger color, essentially I could go right. If I need a smaller color, I could go left. But then I will lose the ordering unless I do some sort of mapping of the indices as well.
Yeah, ordering is important because ordering will tell
Yeah.
you because you're trying to find the distance based on your relative index, right? So if you sort it, you lose the indexing, or you lose like where it is in the array.
Yeah, so definitely there needs to be some sort of um so some sort of prefix type of idea where like I need to store the data from before and then so essentially once I let's say once I do the 1 3 query, so essentially starting from index 1, I know that the minimum distance to 3 is 3 steps away. So I need to save that information somehow. So if I ever want to do that query again, um, essentially let's say I do it from here, or let's say if there's I have some more ones on or whatever. Let's say I have 0 or anything. So let's say even if I do the query from here, whenever I hit this index and I'm looking for a 3, I know 3 is um, 3 distance away from here.
Mm-hmm.
So from this index, it will be whatever this distance is plus that distance. Does that kind of make sense?
So you're the first time you're gonna look for the three, and then you're gonna store that. The second time,
Yeah,
if you since it's already stored, if you get to a spot that was already calculated before, you'll use it again.
yeah. So like something like maybe we can map like the index and the color to like the distance, something like that, and then maybe um, if we ever hit that index again, so we already know the minimum distance from there,
Okay,
something
I'll
like
give
that.
you like I'll ask you one thing is like, is there a way that as soon as we take in the input, we can pre-compute everything, and then when we run the queries, all the queries will just happen pretty much like all of one time after.
Hmm. Okay. So as soon as we take the input, pre-compute everything.
Like when we look at an index,
Yeah.
pretend we look at two, or we look at one, or sorry, if we look at one here, like is there a way to know where is the closest to, like what index to the right, and what is the closest to the left?
I see. Okay. So since there's only 1, 2, and 3, we can kind of. Mm,
Like you mentioned like a prefix sum or something like that earlier.
yeah. So okay, I was just yeah maybe I didn't read that right. I thought there would be more than 3 colors. So yeah, for 1, we can definitely ask. So if you come here, we can ask well where's the nearest 2 and 3. So essentially this will be here and here. The next one, if it's still a 1, essentially it'd just be like whatever the minimum is. If it's to the right, if you move to the right, it'll be if the answer was to the left, it will increase by 1, and vice versa. So if the answer was to the right, it will decrease by 1. So we can kind of keep track of that for all these ones. We don't really have to pre-compute it. And if it's like something new, then we'll we'll try to compute the other two, if that makes sense. So let's say so for this one, um, so for here maybe we can compute the distance to the nearest 2. let's see, 1, 2, 3, 4, 5. So it's distance to 2. I'll start as 5, and then distance to 3 is 7. When we move to the right, for this index, it will be 4 and 6. When we move to, so it'll just keep decrementing like that, depending if the answer is to the left or right. But as soon as we, let's say, hit the 2, now we'll need to look for 1s and 3s, if that makes sense. And I can like hash each index to like, so I can create tuples like this, where the first one will be the index, second one will be like the destination essentially, or the target, and then I'll map it to the shortest distance. And I'll just do this for all the indices. And for each of the queries, then I can just return like this tuple of the queries.
The tuple of index 2. Wait, can you repeat that
So
again? Like, sorry, good. So
so so let's say I have some sort of hash map,
yeah.
and then I'll essentially take the index, and then sorry, not the index. So source, let's say like from what number? I don't know. Okay, index, and then I want the shortest distance. So for each index, I'll have like stuff like this. And then this will map to, so one of them will map to 0 because it'll just be itself. For example, here, from distance from the 0th index to 1 is 0. Shortest distance from this index to 2 would be 1, 2, 3, 4, 5. And then to 3 would be 7. And then essentially I can look these up and just get the answer like that.
Index. What's index? Okay, the index, current index, and the furthest to 1 is 0.
Yeah. And then the current index furthest to 2 is 5. Current index furthest to 3 is 7. And then as long as they're adjacent, so essentially as long as we're moving from 1 to 1 or 2 to 2 or something like that. So if like if they're equal to like the previous value, we can just the answer, we can just increment it or decrement it accordingly. And if it's not, so for example, if you go from this 1 to 2, we'll have to like run a new loop and figure out the distances. So from 2, then obviously from 2 to 2 it'll be 0. From 2 to 1, the distance will be 1, and 2 to 3 the distance will be 2. We'll record that and then kind of just move on along.
Let's see.
Yeah, that will be pretty.
So for every index, we're gonna calculate this for every index. So there's gonna be one for index 0, one for index 1.
Yeah, so that wouldn't be very.
It's gonna be O of n squared again, right?
So essentially the only optimization here is if you have like a lot of adjacent ones, you don't have to loop through it again. So, but if you don't, yeah, it would be technically O of n squared again. Yeah, it's definitely not a great interview.
So yeah, in this one, it'll be O of n squared to figure out the hash map here. Because for each one, you're gonna look for the closest one and record that. Then you're gonna go for every index, you're gonna look for the closest 1, the closest 2, the closest 3. And to do that, you're gonna like spread out from each index.
So, okay. or maybe let's take a completely different approach. I'm sure I'm out of time,
So we have a couple
but
minutes left, so just shoot one more shot at it.
okay, let's maybe we can phrase it as a graph question where like
Okay,
the
I don't know
zeroth
if it'll
node
be a graph. I can
would it
let
be
me explain it. Let me give you a small hint.
okay.
So you're familiar? Could you command Z?
Sorry?
Could you command Z? Could you delete it?
Oh,
So are you familiar with prefix sum or something?
yeah.
So what you're gonna do is you're gonna maintain a left hash map and a right hash map, right? So you're gonna do two loops, one where you move from left to right and one where you move from right to left. And here, pretty much when you're moving from the left, when you start at the zeroth index, when you're moving at if you're at the zeroth index, you're gonna calculate a few things. Maybe we'll store like a hash map here. But from the zeroth index, the closest one that we're to a zero is like probably negative infinity. The closest one that we're close, or for one, it's zero. Wait, one we colors are one, two, and three, right? Okay, one would be zero, right? This would be negative infinity. Negative infinity. Okay, then we move to the right, and then for this index, since it's a one again, it's gonna be zero, negative infinity, negative infinity. But pretend it was a two, right? For index two, what we're gonna say is, when we get to index two, how far is the closest one? It's one plus this one. How close is the closest one? So that's one. And it's gonna be zero here, and negative infinity, right?
I see.
So now we know if we do it from the right as well, but then we do it from now, and then we also do it from the right, we get the same thing. But essentially, when we run queries, we could say, okay, two, where is the closest one? Well, it's the closest one is one to my left, and then we could look how close it is to my right and take the minimum of those.
I see. So some sort of yeah, some DP type of idea.
Yeah, it's kind of yeah, it's definitely it's like caching it.
Yeah.
Does that make sense? Why that would work?
Yeah. Yeah, for sure. Mm.
So I'll send the code here. Something like it's a lot of it's a lot of code. Sorry for giving you a ton of code at two. Paul, this is interesting question too. Well, I don't even know. I wrote a ton of code, but you can see here.
I see. Yeah. Well, I'm not too bummed I didn't get this one, but for sure the first one I should have got it in like 5 minutes.
Hmm.
But I'm just coping by saying it's 2 a.m. But for sure I definitely
You gotta
gotta
lock in for that,
practice
yeah.
some more. Yeah.
So, where are you aiming? Like what companies?
Mostly just like the mid-level companies. Like I have OA coming up for. I got the OA for Intuit, I believe, or it might not be Intuit, it might be something else. Like not definitely not Fang or anything like that. I don't think I'm prepped for that just yet.
Yeah. Cool. So, what are your thoughts? Like, what do you think you could do to improve here, and like, what are some of your pitfalls that you can like self identify?
Yeah, definitely. I need a lot more practice. Maybe just do some more dry runs before heading into implementations. Like definitely for the first example. Uh, yeah,
Yeah.
and the next one I'll try not to do it at 2 a.m.
All right, 100%. Just hit me up when the next one is. We'll do.
Yeah,
I'll
for
do more
sure.
scheduled ones.
You usually do like what's your usual schedule like when you do mock interviews?
I usually do it honestly probably the same time, but usually 5 p.m. PST. But
5
today I
p.m.
was
So like
watching a
8.
Knicks game, so I hopped on after the Knicks game, which was 8. So it's only right now
I
it's
see.
10 or 11 for me, but
I see. Yeah, yeah. So like around 8 p.m. Yeah, that
yeah,
should be good.
yeah,
Cool. I'll definitely try to catch it earlier on next time.
yeah. I think the main thing is you could just simplify your code a bit. So
Hmm.
once I gave you the way to simplify it, you were able to finish it quick. Like usually when the code is really complicated, it leads to a lot of bugs. And then the
Yeah,
other
for
thing is
sure.
handling the edge cases. Your code was tripping out when you were at the 0th index or the last index, and then your code was also tripping out if n was equal to 0. So capturing the edge cases, making sure that your like algorithm can solve the edge cases is just where it tripped up on. So I'll just make sure. I mean, it's all just practice, right? So
Yeah.
just keep
So
practicing, just make sure.
yeah, essentially just dry running and thinking about edge cases before implementing stuff like that.
Yeah, exactly. Cool. Thanks for
Cool.
hopping on. Definitely hit
Yeah.
me up when you like keep practicing, and we're gonna run. We'll get you right for the interview season. It's coming up. I mean, you should probably start ramping up soon because your interview recruiting
Yeah,
season is
for
gonna start.
sure.
It's gonna start August, September, October, November. Like you should start ramping up ASAP.
Yeah, yeah, definitely.
All right.
Yeah. I'll see. I'll talk to you soon.
All right, man. Thanks for hopping in.
Later, man.
Peace. See. All right, chat. Thanks for hopping in. We're gonna stream again tomorrow. I killed a lot of time with that. I killed a lot of time with that metaverse interview.